Hello, good morning student. How are you? Okay, in the last class I have discussed about combination of capacitors. Means the capacitors are in series connections and capacitors are in parallel connections. Now today I discussed about how to find the equivalent capacitance when capacitors are in mixed connections. Means either they are connected in series and parallel both, or sometimes you will be confused that where as the capacitors are connected in series or in parallel. So let us see the how to find out the equivalent capacitance. So equivalent capacitance, equivalent capacitance, equivalent capacitance. You know that when capacitors are connected in series, suppose these three capacitors or two capacitors, these three capacitors are connected in series, capacitance is C1, C2, C3. Then the reciprocal of their equivalent capacitance, that is C equivalent, 1 by C equivalent is sum of the reciprocal of their individual capacitances. Means 1 by C1 plus 1 by C2 plus 1 by C3. And the capacitors are connected in series. And when capacitors are connected in parallel, then capacitors are connected in parallel, so C1, C2 and C3. Then their equivalent capacitance is C1 plus C2 plus C3. So these 2 points we have already discussed. And today we will discuss about some questions. Okay, some numericals, how to solve the equivalent capacitance. Then first step, we will see that what will be the equivalent capacitance of this combination. Suppose three capacitors are connected like this and again they are connected like this. While connection method, their capacitance are equal, capacitances are equal. This is point A and this is point B. You have to find equivalent capacitance between A and B. So between A and B point you have to find the equivalent capacitance. How to find the equivalent capacitance? So firstly, you consider that these 2 points A and B, they are connected with a imaginary cell with potential difference is V. Potential difference is V. Now when the potential difference is V, so at this point potential is also V, and at this point the potential is 0. If this point is V, then this point is also that the potential difference is V. So this point A is at potential V, whereas point B is at potential 0. Now, so this point is at potential V, and you see this point is also at potential V, because in between there is no capacitor or no resistor. So this is also called short circuit connection V. And as this potential is 0, so at this point potential is also 0. Okay, is it clear? So potential is also 0. So now we have to draw the equivalent circuit first, and then we have to find out the equivalent capacitance. So what will be the equivalent circuit? The equivalent circuit is, this is point A, this is point A, and this is point B. This is at potential V at potential 0. So you see first capacitor is connected is connected between potential V and potential 0. So this is first capacitor is connected between potential V and 0, its capacitance is C. The second capacitor is also connected between potential V and 0. So second capacitor is also connected between V and 0. And third capacitor is also connected between potential V and 0. So third capacitor is also connected between V and 0. And their capacitances are equal. Then now, how are they connected? So they are connected in parallel. So it is clear from this diagram, okay, that they are connected in parallel. But here it is difficult to find whether they are connected in series or they are connected in parallel. So now, when they are connected in parallel, you can easily find out the equivalent capacitance. So what will be the equivalent capacitance? So therefore, C equivalent capacitance is C1 plus C2 plus C3 is the formula. So C plus C plus C. So C plus C plus C means 3C. This is the equivalent capacitance. Is it clear? Okay. So let us try another problem. Suppose this is capacitors of capacitances C. All have equal capacitance. Okay, all have equal capacitance. Now, this capacitor is connected with this point, and this point is connected with this point. You have to find out the equivalent capacitance between point AB. So find CAB, equivalent capacitance. Okay, find CAB, an equivalent capacitance between A and B. So again, you can consider that this is connected with an imaginary cell with potential difference in V. So at the point A, suppose this is positive and this one is negative. So potential at the point A is V and potential at the point B is 0. And this is potential at B. So what will be the potential at this point? You cannot say that it is V because in this part one capacitor is present. Okay, so you cannot say that at this point the potential will be V. So you do not know what will be the potential at this point. So that's why you take the point as X potentials. Okay, and as the potential at this point is X, so potential at this point is also X because in between this path there is no capacitors. Okay, similarly you consider that point B is at 0 potential. So again, what will be the potential at this point? It will not be 0 because in between the path one capacitor is present. So what will be the potentials? Again you do not know. So let it is Y. It is Y. Then you see, so at this point what will be the potentials? Again Y. Again Y, because they are directly connected. In between there is no capacitors or no any other devices. Okay. So now how to draw the equivalent circuit. So what will be the equivalent circuit of this circuit diagram? So point A, this is point A, potential B, this is X potential, this is Y potential, and this potential B. Potential B, means 0 potential, point B. Now the first capacitor is connected between V and X. Potential V and X. So potential V and X, first capacitor is connected. Capacitance C. Second capacitor is connected between potential X and Y. X and Y. So between X and Y, the second capacitor is connected between X and Y. Third capacitor is again connected between X and Y. X and Y. So between X and Y, the third capacitor is also connected. The fourth capacitor, it is again connected between the potential X and Y. So again, fourth capacitor is connected between point X and Y. And the fifth capacitor is connected between Y and 0 potential. So Y and 0 potential, fifth capacitor is connected. So now it is easy for you to calculate the equivalent capacitance. So these capacitors are connected in parallel. So what will be their equivalent capacitance? Just sum of their capacitances. Means C plus C plus C. Means 3C. Okay. So equivalent capacitance of this combination is 3C. Then what will be the again equivalent circuit diagram? So equivalent circuit diagram is this is point A. This is capacitor of capacitance C. And for this you can write 3C. So this is 3C. And this one is C. Again. C. A point B. So now how are they connected? They are connected in series. So what will be the equivalent capacitance now? So therefore equivalent capacitance as they are connected in series. So this is equal to 1 by C1 plus 1 by C2 plus 1 by C3. 1 by C3. Means this is equal to 3C. So 3 plus 1 plus 3. Okay. Means 7 by 3C. So 1 by C equivalent is 7 by 3C. 7 by 3C. So therefore, what will be C equivalent? C equivalent will be 3 by 7C. 3 by 7C. This is the equivalent capacitance of these combinations. Is it clear? Okay. Now, let us see another numericals. Okay. Suppose the combination is like this. This is point A, this is point B. Two capacitors are connected like this, and this is one capacitor and here another capacitors. All have equal capacitance C. So what will be the equivalent capacitance between A and B? What will be the equivalent capacitance between A and B? That we have to find out. So find equivalent capacitance between A and B. So again, you can connect an imaginary cells between point A and B and take A is positive, B is negative, and the potential difference is V. So suppose this potential is V and this potential is 0. Or at this point potential is V, so at this point potential is V, at this point potential is V. Okay. So at this point potential V, at this point potential V, at this point is also potential V. Whereas when potential is 0, so at this point potential 0, at this point potential 0. Okay, this is also 0 at this point. But here you see, at this point potential 0, so at this point potential cannot be 0 because in between one capacitor is present. At this point V, so here the potentials cannot be V. Okay, because in between one capacitor is present. So what will be the potential at this point that we do not know? So let it is X. It is X. It is X. Then draw the equivalent circuit diagram. So what will be equivalent circuit diagram? First step, equivalent circuit diagram you draw. So this is point A, this is point B, and this is point X. This is point X. A, B and X. A potential, this is B, B potential is 0, the X potential. Okay, so this is first capacitor. So it is connected between potential V and X. V and X. So V and X. The capacitor is connected. Okay. These two capacitor, how this capacitor is connected? Between 0 and X. So between 0 and X, another capacitor is connected. Between 0 and X. 0 and X. And this capacitor is connected between V and X. Again between V and X. So between V and X, another capacitor is connected. Between V and X. And how this capacitor is connected? Between V and 0. V and 0. So this is V and this is 0. So how this is connected? Between V and 0. between V and 0. So this is the equivalent circuit diagram. Okay, all have equal capacitance C. Now, how are they connected? They connected in parallel. So what will be their equivalent capacitance? C1 plus C2 means C plus C, that is 2C. Okay, then again draw the equivalent circuit. Okay, what will be equivalent circuit? Now this is point E, this is point X, and this is point B. So point E, these two capacitors are connected in parallel, and their equivalent capacitance you know C and C. So it is 2C. It is 2C. And then X and B, another capacitor C, this is C. And between A to B again C is there. Again C is there. Okay. Now how are they connected? They are connected in series, and with this combination again this is connected in parallel. So what will be the equivalent capacitance? That is very easy for you, and you can easily calculate. Okay, so what will be the result? You see, again draw the equivalent circuit. Equivalent circuit. So this is capacitance C, and using these two, again you will get another capacitor. Another capacitor. So what will we see here? And these are connected in series. So when they are connected in series, what is equivalent capacitance? C1 into C2 by C1 plus C2. This formula you know. So C1 into C2 means 2C into C. 2C into C by 2C plus C. So 2C square by 3C. 2C square by 3C. C cancel. So 2C by 3. So this is 2C by 3. So tell me how they are connected now, parallel. Then what will be the equivalent capacitance? So therefore CAB equivalent capacitance, they are connected in parallel, means C plus 2C by 3. So that is 3. So 3C plus 2C by 3, that is 5C by 3. Is it clear? Is it clear? Okay. So in this way, you can find out the equivalent capacitance. There will be many type of combination. Just you have to identify. Okay. This is using potentials method. Okay. Then next numericals. One more. Suppose these two capacitors. This is point A, this is point B, capacitance CC, and again another capacitors are also there, CC. All have equal capacitance. Okay, you have to find out equivalent capacitance between A and B. Find equivalent capacitance between A and B. Here also we can use the potential method, okay, or we can use that. Here you see how are they connected? They are connected in series. How are they connected? They are connected in series. How are these two connected? They are connected in series. How are they connected? They are connected in series. So if they are C and C, they are connected in series. What will be their net capacitance? C into C by C plus C means is equivalent capacitance is C into C by C plus C means C square by 2C in C by 2. So for this is called equivalent capacitance of this is C by 2, equivalent capacitance of this is C by 2, equivalent capacitance of this is C by 2, equivalent capacitance of this is C by 2. So all these four combinations, then how are they connected? They are connected in parallel. You see. These points and these points, okay. Again, all these points they are connected together. So how are they connected? They are connected in parallel. Then what will be their equivalent capacitance? Just like this, as they are connected in parallel. Okay. So this A and B and all C by 2. C by 2, C by 2, C by 2 and C by 2. The equivalent capacitance. Okay, then what will be the equivalent capacitance? Therefore, CAB, this is C by 2 plus C by 2 plus C by 2 plus C by 2. 4 into C by 2. So 4 into C by 2 means 2C. So what is the equivalent capacitance? Equivalent capacitance is 2C. Okay, is it clear? Okay. Now again, using another method, we have to find out the equivalent capacitance. Okay, so let us see, and that method is Wheatstone-Bridge method. Wheatstone-Bridge method. So Wheatstone-Bridge method. Wheatstone-Bridge method. Wheatstone-Bridge method. In Wheatstone-Bridge method, you know that suppose these are the combinations of capacitors is like this. This is point A and this is point B. Suppose capacitor C1, C2, C3, C4 and this is C5. Okay. This figure looks like Wheatstone-Bridge. Wheatstone-Bridge. And this will be a balanced Wheatstone-Bridge if for balanced Wheatstone-Bridge, for balanced Wheatstone-Bridge, for balanced Wheatstone-Bridge, for balanced Wheatstone-Bridge, C1 by C2 is equal to C3 by C4. This formula you have to remember that for balanced Wheatstone-Bridge, C1 by C2 is equal to C3 by C4. And when the bridge is balanced, so no charge will pass through this path. No charge will pass through this path. Means potential difference between these 2 points will be 0. So if the potential at this point is x, then potential at this point will be also x. Means the potential difference will be 0 and no charge will pass through this path. So if the bridge is there, if you see that C1 by C2 is equal to C3 by C4, so no need to put these capacitors because this will be useless. Through this path, no charge will pass. That's why this will be useless. Then, if this is not present, then how these two are connected? They are connected in series. How these two are connected? They are also connected in series. And then again these two combinations, how are they connected? Now they are connected in parallel. They are connected in parallel. Okay? Is it clear? Okay. So using Wheatstone-Bridge method, now we will solve one numerical. Okay. So let us see. Suppose these 3 capacitors, and in between again you see is capacitors. Point A and this is point B. All have equal capacitance C. All have equal capacitance C. You have to find equivalent capacitance between A and B. Find CAB, equivalent capacitance. Okay, so here also again you have to draw the equivalent circuit diagram. So how to draw the equivalent circuit? Here you see, first you consider that this is connected with an imaginary cell with potential difference is V, and this is a positive potential, this is a negative potential, zero potential. So its potential is V and its potential is 0. So here you see potential is V, its potential is V. So at this point you cannot write the potential is V because in between one capacitor is there. So take this at this point the potential is X. Okay. Again at this point potential V. So here you cannot write the potential V. Okay. Here you cannot write the potential V because in between capacitor is there. So suppose at the potential is Y. Potential is Y. So this is X. This is X. And at this point potential is 0. So now you draw the equivalent circuit. So how many points are there? A, X, Y and B. So this is point A, this is point B, this is suppose X, and this is suppose Y. So first capacitor, how it is connected? Between V and X. Between V and X, the potential is V, the potential is V and X. V and X, first capacitor of capacitance. Second capacitor is connected between X and Y. So between X and Y, second capacitor is connected. Third capacitor is connected between Y and 0. So between Y and 0, third capacitor is connected. Okay. Then fourth capacitor is connected between X and 0. Between X and 0, the fourth capacitor is connected. And the fifth capacitor is connected between V and Y. Between V and Y. So between V and Y. Between V and Y. And all have equal capacitance. Okay. Now you see that this diagram looks like Piston bridge diagram. Piston bridge. And in case of piston bridge, we know that if C1 by C2 is equal to C3 by C4, then that piston bridge is a balanced piston bridge. And in that case, no charge will pass through this path. Means potential at this point and potential at this point will be same. Okay. So here you see C1 by C2 means C by C is equal to C3 by C4, C by C. So this is a balanced piston bridge. So and C1 by C2 is equal to C3 by C4. So the bridge is a balanced Wheatstone bridge. Balanced Wheatstone bridge. It is a balanced Wheatstone bridge. So there is no need of using these capacitors. Then how to draw the equivalent circuit again? So therefore equivalent circuit will be again, this is point A. So this is capacitor, one capacitor, this is point X, this is another capacitor, it is C, okay, and this is capacitor, this is point Y, and this is another capacitor, this is point B. So C and C. So now C they are connected in series, and this CC they are connected in series. Then if they are connected in series, then again you draw the equivalent capacitance. So this is the equivalent capacitance, and again these two is the equivalent capacitance 1. So what will be the equivalent capacitance if C and C are connected in series? C into C by C plus C means C by 2. So this is C by 2, this is also C by 2, and this point A, point B. Now how are they connected again? Parallel. So if they are connected in parallel, what is the equivalent capacitance? C equal to C1 plus C. So means C by 2 plus C by 2. That is C only. Okay. So therefore CAB is C1 plus C2 means C by 2 plus C by 2. So this is equal to C. This is equal to C. So is it clear? So another method is also there. One is that is infinite network. If infinite network is given to you, then how to find out the equivalent capacitance for infinite network? For infinite network of capacitors. Infinite network of capacitors. Infinite network of capacitors. If infinite network of capacitors, then how to calculate the equivalent capacitance? So suppose this is point A and this is an infinite network of capacitors. This is point B. Capacitors are connected like this. There are 2 microfarad, 2 microfarad, 2 microfarad. This is 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad. And this is infinite network. Infinite network. Then, how to calculate the equivalent capacitance between A and B? Find equivalent capacitance between A and B. How to calculate in this case? Here you see, as the network is an infinite network, so let us take the equivalent capacitance is X. Equivalent capacitance is X. Let equivalent capacitance is equal to X. Okay, so if the equivalent capacitance is X for an infinite network, so if you leave 1 unit, you see this system is repeated. This system is repeated. 1, 2, 1, 2, 1, 2, 1, 2, like the system is repeated. So if you leave one system, one unit, and take this unit up to infinity, then what will be the equivalent capacitance of these combinations? This will also be X. Then how X is connected with this and this? Okay, then X is connected with this in series and again with this. So what will be the equivalent circuit diagram? So equivalent circuit diagram will be, this is point A, this is 2 microfarad. Okay, this is point B, this is 1 microfarad, and the equivalent capacitance of this combination is X. This combination is X. Suppose this equivalent capacitance is X. This is X. This is X. Now, how X and 2 is connected? They are connected in series. And with the series combinations, one is connected in parallel. Okay. Then again, what will be the equivalent capacitance as they are connected in series X and 2? So X into 2 by X plus 2. That is 2X by X plus 2. So here, equivalent circuit again we will get that 2X by X plus 2. This is 2X by X plus 2. With this, how this one is connected? This is point A. How this one is connected? This one is connected in parallel. With this system, this is connected in parallel. So this is A and this is B. Okay, this is 1 microfarad. 1 microfarad. Now how are they connected? They are connected in parallel. So what will be their equivalent capacitance? Again, equivalent capacitance will be X. Again, because it is infinite network. So here, what will be the equivalent capacitance? That is connected in series. So therefore, CAB is equal to 2X by X plus 2 plus 1. And that is equal to X again. And that is equal to X again. As the network is infinite network. So therefore, you can write that X is equal to 2X by X plus 2 plus 1, or X is equal to X plus 2, so 2X plus X plus 2, or X is equal to 2X plus X means 3X plus 2 by X plus 2. Now cross multiplication, so X square plus 2X is equal to 3X plus 2, or X square 3X on left side. So this is minus X, minus 2 is equal to 0. Again middle factor, so we will get X minus 2 into X plus 1 is equal to 0. So from this, you can X is equal to minus 1 and X is equal to 2. But minus value is not accepted here. The equivalent capacitance cannot be minus 1 microfarad. Then what will be the equivalent capacitance? 2 microfarad. Therefore, your answer is X is equal to 2 microfarad. The equivalent capacitance of this network is 2 microfarad. Is it clear? Okay. Thank you.